I'm Philipp. Today we'll talk about pain-free object document mapping for MongoDB. So I'm from Vienna, city of fatty foods, classical music, and beautiful buildings. And there I also organize some meetups like VienaDB about databases, which kind of fits what we're doing today. And also Papers We Love Vienna, which is more on the theoretical side, but also touches a lot of database and distributed stuff. And I work at a company called Ecosio, which does electronic data interchange, where we try to get rid of paper for ordering invoices. So like when supermarkets order something, they shouldn't do it by hand, but in an automated fashion. And that's where we also gained our experience with MongoDB. So who uses JPA? A few, okay. Who uses MongoDB? Very nice. Who has heard of Morphia? Also a few, okay. But we still got some work to do. Okay, so Morphia is basically like JPA for MongoDB, but it's kind of better, both because of MongoDB and because of Morphia. So if you're using JPA, who's used something like this? Yeah, so a two-way join. Do you think this is okay? You do. Yeah, probably in kind of this fashion. So you're either in denial or it's kind of the Stockholm syndrome, but I don't think this is really much okay. So what's the problem? You have your relations and your objects, and you have the impedance mismatch between the two, so they just really don't work together. So you have your rich object structure on the one hand side. On the other side, you have your relations, and you kind to knock it down, so together over that barrier, so the two just don't really fit that well together. And MongoDB, with its document structure, does that quite better. And there's also this famous saying, ORM is the Vietnam of computer science, which is already 10 years old, the paper. So that was kind of the dark ages of ORM, when Hibernate was just about to start, but it still has some kind of merit. So let's talk about MongoDB. We're storing JSON documents in the database. So just to get some terms right, first, instead of tables, we have so-called collections. So you have kind of one kind of documents go into a specific collection. So for example, you would store your people or whatever in a people collection probably, like you would in a table, but you don't have a schema. So it's not really enforced, but it's kind of a logical selection of what you put together. And instead of a row, you have a document. And of course, because it's all the rage at the moment, it needs to be JSON. So that's what one of the documents might look like. For example, you have always a key and then a value, which is a string, a Boolean value, an integer, floating value, or a subdocument. Here, inside this person document, I have modeled an address document. So it's just stuffed right in there. And here we have an array of objects again. So we have possibly multiple phone numbers, and then we can have types and numbers, which is kind of nicer than in the relational world, because there you have a field for phone numbers, and what do you do if someone has a second phone number? So you can either have another row with many null values, or you can just join it together, but both are not really the nicest solutions. And what happens if somebody has a third phone number? And yeah, it's kind of weird. With JSON, it's much simpler because you can simply have your array and then stuff into it whatever you want. And just to give you a quick intro to MongoDB. So let's see, I hope you can read that. So to connect to MongoDB, I'm just using Mongo on localhost, and I've configured the port 8082. But it doesn't really matter. So by default, we are connected to the test database. And just to show you, there are very few databases. And to use a new database, you don't have... Oh, thanks. That's somewhat cut off. Give me a second. Okay. Okay, I hope you can read that. So just to show you, to use a new database, you don't have to create it, since like with the schema, there is no schema, you don't have to create anything, you just start stuffing stuff into it. For example, if I use the database Kiev, it's just there, and now I can simply insert something. So I have already copied it, just to save the typing. So here, into my database, I want to insert a person, and the person has the name Philipp, and an array of 2 phone numbers, so a mobile number and a fax number. So while I personally wouldn't use a fax number, yeah, I've just added it here. So let's try to get that in. Okay, so good. So if I insert that, okay, everything went well. So if I just want to search for it again, I can simply do db person find, and then I find my person. Nice. So if I want to add another person, for example, I will add my friend Peter, and he has just a landline, let's say. So I've got here a landline, and he's called Peter. We've inserted him, and now if we search, we still got me, and we still got Peter down here. And so you stuff in JSON, you get out JSON, and to write queries, you write JSON again. So if I wanted to find every person who has, so I'm doing a JSON document here, and I now want to say everybody who has a phone number of the type landline, it should only find my friend Peter, and it did. So that's basically what you do with MongoDB. You store JSON, you query with JSON, and you get JSON out, so everything JSON. It might be a little harder than typing SQL, but you will hopefully get used to it. Okay, so we have our documents in the database. Now how do we interact with it with Java? There is a Java driver provided, and it looks something like this. So just to get the previous document into the database from Java, you would do something like this. So you also have this basic DB object, and then you stuff in all the attributes. And if you have a subdocument, you make another basic DB object and stuff it right in there. And if you have an array, you do an array list, and you stuff your DB object in there, and it was kind of tedious. And when I suggested to my college that we use something like that, the reaction was like, are you serious? I mean, really, do we have to interact with it like that? And then we said, okay, no, we don't want to do that. So that's why we came to Morphia, which is now the Java driver is like JDBC, and Morphia is like JPA on top of it. So it just provides a nice mapping based on POJOs and annotations. And feature-wise, it's pretty lightweight, and it's type safe and type preserving. So you don't have to do any casts or anything other weird stuff. It will just give you back whatever you want. So what you use, those are the current versions. So with the Java driver, we're at 3.0, and Morphia is finally getting its 1.0 release, though we have been using it in production for many years, but now it's even officially blessed to be final. So if you want to try out the code, that's the repository where you can just clone it, and all the examples we have, you can just run yourself. And it's very nice. So this is kind of what you get. So we have a basic entity, and based on that base entity, we have two main entities, companies and employees. And both of these have bank connections and addresses. So those are just embedded documents in them. And the employees are further split down into workers and managers, just to give you the idea. So that's what we're basically aiming for, and now we'll go over it, how we do it. If you want to try it out yourself, to run the code, just run Gradle test. You don't need MongoDB locally. It will just download MongoDB and run it in an embedded fashion on the default port, if you don't have it installed. If you have MongoDB installed on the default port, it will just take that. So it's pretty easy to get started with the code. So let's cover some annotations. first off, the collections. So that what was tables in the relational world are the collections. And if I wanted to store my company, I would just say it's an entity. I want it to be named company in the database. I don't want to store the class name with it right now. We'll come to that a bit later. And then we have an ID, which is an object ID. We'll come to that later as well. And you need a default no args constructor, just so Morphia is happy, but otherwise that's pretty simple. If you would leave out the value of the entity annotation, the collection would be called company entity, but we want to keep it nice and simple and lowercase, so we just say explicitly, okay, we want just to have it called company. So stuff to avoid. Do not put dashes in the collection name. Does any one of you have an idea why you should avoid that? Keep in mind the shell I've just shown you of MongoDB is based on JavaScript. Any ideas what could be a problem there? Sorry? Yeah, right. So you have then two strings which you try to just calculate from each other. So if you know the Gary Bernhardt talk, which was very nice, so he showed it very in a nice fashion. So he had, in JavaScript, he had an array of 16 elements which was empty, so you get 16 commas, okay. Then he wanted to join what 16 times and got what, okay. Then he added 1 and got what 1 16 times. And now, yeah, at the end he gets na Batman, because it's not a number, because it tries the string and then subtract 1. And that's basically what the shell tries to do as well. So you can work around it, but it's kind of tedious. And the Java driver will nicely map it away, but as soon as you're on the shell, it won't work that nicely. So try to avoid that. Also, do not copy the value of the identity attribute, because since there is no schema, it will just stuff totally unrelated classes or objects into the collection. So you then have your companies and your persons all stuffed into a single collection called company or whatever value you copied, and you won't even notice because there is no schema to warn you. And be careful, don't use ID as string without a good reason, because it might break some stuff. So let's get to another nice feature, polymorphism. Assume we have a simple class like this. So we have an abstract base class with an employee and two specifications, a manager who can approve funds and a worker entity who have years of experience. Obviously, managers don't need experience. So we want to store that. And in a relational database, you have three options. So you can either have a union table with possibly many null values. So if you just have two specifications and they just each have one distinct attribute, it's probably fine. But if you have many specifications and many different attributes, you will have many null values in your relational database. Not so nice. The other approach is have concrete instances. So you would have a table worker and you would have a table manager. They would work on their own pretty well, but now how do you get all the employees? So then your application would need to get all the workers and all the managers, and then would need to put them together somehow. Or you could have a base table and then join in the specific attributes of each specification. But here, yeah, well, you need the joins and you kind of try to avoid them. It's a little more work with the queries and yeah, not so nice. Yeah. So let's try to take the pain away and see how MongoDB does that. So we throw in a couple of annotations. So we just say, yeah, this should be, so on the abstract class, we just define this should go into the employees collection. We have our ID and the name, which we have in all of them. The specifications are, the specific implementations are just the same. And here we say no class name stored false. So actually we do want to store the class name with them. And what this looks like in a database is this. So since you don't store any null values in the database, you just get the real stuff you want to have. And based on the class name, you can nicely keep them apart. And just a pointer, does anyone have an idea why we have this ugly object ID? Because in relational databases, you have your nice auto-incrementing or serial IDs, which would be 1, 2, 3, 4, whatever. And this is kind of stupid if you want to communicate with someone else. So if I tell my colleague, yeah, we have a problem with that customer, and he has the idea of 524D9FE, whatever, that's not so nice to communicate. So do you have any idea why MongoDB does that? Yes, so it's easier to generate that. So normally this is generated on the client. So there's an algorithm behind it. You have the hash of the MAC address and the process ID and the counter and the second. So you don't need to have a single instance to generate the IDs, and you can simply generate it on the client. Yes, thanks. So we have that in the database. And now some of you might say, okay, what happens if I want to refactor my code? Because now I have this very long class name in my database. Yes, it's not so nice. So you have basically two approaches. Either when you update your application with the refactored code, you need to have an update query where you simply say, okay, wherever I have the class name, la 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 la, employee entity, I want to have it whatever else employee entity or however else you rename the class. So you can either do that, or you say, okay, I want to do that pretty often and I don't want to do all these queries then. Instead of storing the class name, you just could create your own enumeration and then stuff the enumeration inside the documents, and by that you could make the difference. Yeah, so now that we have our collections, let's see how this goes for properties. So if you do not annotate a property like the first name, it will just be stored like this, first name in the database as a field. If you want to rename a field, Morphia also supports this quite nicely. So the database or the application will look into the database and say, do I have an attribute that's called surname? If yes, load it into the string surname. If you don't have the surname, look into the database and see, do I have something that's called last name? And then load the last name into surname. So if I've renamed the field, you can automatically map that here. Yeah, you can have your booleans. You can shorten attributes names. So instead of manager can approve hires boolean, I can just call it hire. And yeah, chainable setters are also nice to have. So first off, try to shorten your property names, at least with the currently default storage engine. The problem is, since you don't have a schema, you're storing the property name in each single document, both on disk and in memory. So this is quite an overhead, especially if you just have a Boolean flag and then it has the name manager can approve hires. You're really wasting a lot of time, especially if you have many, many documents. So some have this pattern that they just shorten it down to a single letter in the database, but in the application they have a nice speaking name. So Morphia will do that for you. Use object data types. Do you have an idea why we should probably use object data types instead of primitives? Exactly. So with primitives, you don't have a null value, so it will always be written as with the default value. For example, a Boolean will also always default to false. But if you don't even need to have that attribute because it's optional, just use the object data type, and then it won't end up in the database. And yeah. As I said, chainable setters are kind of nice. Indexes. They're the #1 way to improve the performance of your database, like in relational databases, and they also work just the same. So they are a B-tree to make your queries much faster. You can quite easily define them. Again, if you have your employee entity class down here with my email address, I say I want to have an index, and the index should be unique. So every email address can only appear a single time, and setting the sparse true or false. With this, I'm also setting that I can only have a single null value, because null would otherwise be included in that as well. If I set sparse to true, the field is optional, and I could have as many null values as I want to have. Yes, please.
Isn't there a bit of redundancy in that you have index definitions both on the class itself and on the specific field?
Yes, the problem is, so we are normally doing the index on, if it's just a single variable we try to index, we use it on the field. But up here, we are using a combined index. So this is both on surname and first name in combination. So this is like the phone book example. If you want to search for persons by surname and first name, this index will help you. So it will help you both if you want to search for surname or the combination of surname and first name. The index won't help you searching for first name. Like in a phone book, if you want to search for first names in the phone book, won't work like that. But that's the B-tree limitation. So if you want to have, so you can define the indexes at the class level, but I find that kind of strange if you to keep it that far apart. So if I can, I try to define it on the attribute, and if I need to have a combination, I need to do it at the class level. Yes, please.
Thank you. Can we specify ascending and descending indexes
yes,
using annotations?
Yes, you can do that, but that will only make a difference if you have a combined index. Because with a single index, it doesn't make much difference, because you can navigate either way. So with a single field, it just doesn't matter, because either you start at the beginning or you start at the end. So the order doesn't make any difference. So if you have surname and first name, by default, they're descending, if I remember correctly. So with this kind of index, you can then search for surname in both directions and surname, first name, if they are both descending or both ascending. But you cannot search for descending surname and ascending first name. So that's the limitation. So the only the only situation where the order or the sorting order of the index makes a difference if you have two or more attributes combined, and if you want to search them in a specific order and not in the one you've given. Yes, but that's generally B trees. Yeah. Let's come to another nice performance feature, optimistic locking. So relational databases are kind of strict, and they also always assume that something bad will happen. So you have your transactions, and you will lock down whatever you want to write, and only after you have successfully finished your write, you will open up the lock, and somebody else can write to your data. MongoDB kind of takes the opposite approach, where it says, okay, I assume everything will go right. I won't stop or I won't make these locks because they're pretty heavy performance-wise. I will just let you go ahead. And what this looks like is you just add your the annotation version, and it's a long. You don't need any getters or setters. And then if you store the document for the first time, it will have a version of 1. And then what happens in the background, you don't need to do that explicitly, but it happens in the background. So every time you update your data, it will check, okay, I have read the data based on version 1. Is that version, when I try to write it back, still at 1? Then I apply my write. If that write is not at version 1 anymore, somebody else has written it to the document, I will probably overwrite the write, so I will throw an exception because we would probably lose data. So here the approach is not the pessimistic one like in relational databases where you assume stuff will go wrong and you just lock it down to make sure it doesn't happen. But here MongoDB just assumes, okay, you probably won't have a collision. If you do, we will throw an exception, but otherwise we will just let you go ahead and make updates as fast as possible. But of course, the application then needs to be able to handle this situation. And you should kind of structure your code to not make that on purpose to have writes on competing on a single document. Something MongoDB doesn't provide are joins. So there are two things you can do to avoid that or work around it. The first one is having documents embedded. Like the address we had in the person, that's an embedded document. If you have some other entity referenced in your code, by default it's embedded, but we're always annotating it with embedded just to make it a bit more explicit. Or if you want to reference it, there is an annotation for this. And this works both for single values or for any kind of list or map. The reference is not a join, it's just a feature of the driver. It's kind of a kind of annotation or that all the drivers support, and it just says, okay, the collection is this, the object ID is that, and if you load the employee object, which references a company, it will automatically eagerly fetch the company for you. So you can already access it whenever you load the employee. If you don't want to load it eagerly, you can also set the reference lazily. So you can just use add an attribute, and then it could be loaded lazily. Or if you just want to avoid all of this referencing, because you can get very deep hierarchies, and then you just access a single document, but in the background the database loads like 20 other documents, especially with lists that you reference. You can just put in an object ID yourself, and if you know what it is and where to query it, you can then only query it explicitly if you know that you need it to avoid the overhead of having it loaded automatically in the background. So now we have annotated everything nicely. Now we need to query it. Save or upsert is one nice feature. So if something has, so if you insert it the first time, it gets an ID. If you just store it back again and it has the same ID, MongoDB will just replace the previous document. So you don't need to do an explicit update. You can just do a save, and since the ID is the same, it will figure out, okay, I'll need to overwrite the old document. So what this looks like is pretty much the same. Kind of a lot of duplicated code. How to work around that will come to in a little bit. So we just use our data store and call save. So the more interesting thing then is, how do I get out the data again? Just 3 simple query examples. So if you have your employee class and you have your field email, I just want to say, okay, the email should be equal to whatever email value I have, and then I will get my employee entity. And since I have set a unique index on the email attribute, I'm sure I will get 0 or 1 entries at most. If I want to get all the employees, you probably only want to do that if you have very little data. You can just say, okay, find my class, and as a list, get me my list of employees back. Or if you only want to get the managers, then we would, since the managers and the workers are then mixed up in your collection, you would then need to specify, okay, I want manager entities, but I want a list of that. So I know the field class name, which MongoDB implicitly puts into my document, is the class name of the manager entity, and MongoDB would then throw a warning and say, okay, you don't have an attribute class name in your code. Are you sure it's there and you want to access it? And because I know MongoDB put it there in the background, I simply say, yes, I know that it's there. I don't want to see any warnings, and I disable validation. That's just because this attribute class name is not explicitly in your code. So watch out. Equal, MongoDB uses, or Morphia uses equal and not equals. Your compiler will warn you, trust him. Normalized fields, just to get quicker queries. For example, emails, doesn't matter if they're upper or lowercase, just store them as lowercase in your database, and then you can do direct exact matches and don't need to use anything like full text search or regular expressions just to get away the upper and lower casing. And there are many, many, many more queries, like you can do regular expressions. You can check, does an attribute exist? Does it not exist? If you have a number, is it greater than something? If you have a list or an array of something, does it contain one of these values? You can sort, you can skip, you can limit, like everything you can do in relational databases. And many more features, like kept collections, where you can simply say, okay, for this kind of thing, for some log or whatever, I just want to use like 100 megabytes. And then it's just written 100 megabytes, and once you've written your 100 megabytes, the oldest documents will be overwritten. So it's kind of the circle, and once you've reached the starting point, you will start overwriting the oldest documents. GridFS is a distributed file system where MongoDB will just distribute your binaries or very large documents for you. You have an aggregation framework, which is very nice. It's kind of the only one in the NoSQL world which has that, where you can do sums, aggregates, group bys, having, average, minimum, whatever, kind of nearly everything you can have in the relational world, you can do in MongoDB as well there. And it has pretty powerful geolocation features. So you can, they're both flat and spherical. So you can just say, give me everything within 1 kilometer of this venue, and then you will get, I don't know, whatever points you have in your database. Patterns. So from using it for a few years, we've kind of developed some approaches which we find kind of useful. The first one is we always use a base class where we just define, okay, this thing has an object ID, it has a creation date and the last change date, and we want to use optimistic versioning. Don't forget the default constructor, but you will get an exception anyway. So we can just get these values. The ID will be generated by the Java driver, so you don't need to do that. And the creation date and last change date, you will just want to query them, because to insert them, we use pre-persist. So right before you insert your data in the database, Morphia will still run this code. So if there is no creation date, just take the current date and then take the current date and always set it at the last change date. So that's easy to set. What you now can use is generics for your queries. So instead of saying, okay, I want to persist a manager and I want to persist a worker and an employee and a company and whatever, I can just say, okay, I want to persist anything that inherits from the base entity. Or I want to count all the elements in a class, whatever class I provide. Or I just want a generic get by object ID, where I provide the class and the idea, and it will then just simply be fetched, and you will also get the right type back again. So generics are fully supported. Converters. MongoDB or Morphia supports a lot of data types, but not all of them. So one very common one that's not supported is Bigdecimal. And you have 3 approaches to work around that. The first one is you can simply annotate it serialized. It will be serialized by Java and then put in the database, which works, but is not so nice because you cannot easily read or search it in the database then. So if you want to do a manual query just to get everybody who has a bonus over 1,000 euros a year, you cannot easily query that from the database. Second approach is just to have the attribute and then say, okay, I don't want to store that in the database, it's transient, but I have a string which will have this value, and then again with my pre-persist and post-load, which will fire just after fetching a value, I'm just using a toString on that, or I'm using the Bigdecimal string constructor to just get back my value, and then I will interact with my salary nicely and just store the string in the database. So that works, but it's kind of ugly. So the third approach is you can register converters, where you simply say either on the class level, or if you set up your data store, you can just say it globally. Whenever I encounter a Bigdecimal, the Bigdecimal converter class will know how to do that. And then you don't need to do anything else. And the Bigdecimal class this is kind of the default implementation. I'm not sure why it's not included in the core, but kind of everybody copies that around if you use Bigdecimal, and it just needs to provide an encode and decode method, and yeah, that's doing all the hard lifting then. So if you want to do more, if you are into Spring Data provides a MongoDB mapper. It's good. If you are into this whole repository thing and use Spring otherwise, I can highly recommend it. It's just as feature complete as Morphia. It's not provided by the same company that provides the database. So Morphia is provided by MongoDB, the company. But Spring is also doing an awesome job, so I'm sure you will be happy with it. Then Foursquare provided Fongo, fake Mongo, which is an in-memory implementation for unit testing. So you don't need to have an explicit you don't need to explicitly start a database, which will probably slow down your unit tests quite a lot. The only downside is that it's not 100% complete, so you can do most of the queries, but not all of them are implemented yet. And something which is quite nice is Critter. It's one of the Morphia developers. And he has, so what Critter solves is, by default, when you want to access an attribute, you still have the string. So you have, for example, I want to get everything where bookmark is equal and database is equal. And you have these strings. And so if you're refactoring your field names, you will only notice if your unit tests break. So what he does is he generates either with Maven or with Gradle. He generates all your fields you have, and then it's explicit Java code, so you will get compiler warnings or actually compiler errors if you rename your attributes. It's not widely used yet, but it looks very useful. So if you plan on doing quite a lot of refactorings, it might be a good idea to take a look at that. And yeah, that's always the question, but is it fast? And this is my favorite description of the is it fast problem. So it will always depend, because under similar conditions, yeah. I'm not sure if the house cat is so much more stupid than the squid, but obviously, depending on what benchmark you do, it is. And just to give you a glimpse into the benchmarking world, Couchbase, MongoDB, and Cassandra, 3 big NoSQL vendors, all did benchmarks in the last few months. And for each time they did a test, their own product was like 10 times faster than the other ones. So each of them was able to find some very specific scenario or some very specific tuning or bad tuning for the others where he himself was just faster. And you will find a scenario, however you will try it, to make one faster than the other. So unfortunately, you will just need to write your own tests. So write a quick prototype and unit test that. I'm afraid there is no global benchmark I can provide. Yes, because that's a common question. But what am I losing? So you don't have transactions. If you have a single document that's written atomically, but there is nothing like having multi-document transactions. So depending on how you structure your data, you might be able to stuff into everything you need into a single document, and then you don't really need transactions. So like writing the address and the bank connection and everything into one person, you don't need a transaction because you have that all in one document. But if you really need to have kind of person A gives money to person B, it's probably hard to implement in MongoDB in a safe way, because you cannot just in a transaction do minus on the one side, plus on the other side. So either you might lose money if the process fails in the middle, or you will just magically create money in your system. There are some implementations where people try to provide transactions in their own application, just on the application level, but I would be very careful if that's really working in 100% of the cases, so I'm not really sure. Yeah, and there are no joins. So if you cannot put it into a single document, your application needs to do the work, unfortunately. What you will get is pretty rapid development, so especially it's nice for prototyping. You don't need to create a database schema. You don't need to change anything in the database schema if your application just adds new data, because it's just automatically created. So replication is very easy, and sharding is also very easy to distribute it over multiple nodes. And you don't have the impedance mismatch, but thanks to the rich document structure, it just fits the object-oriented world much better. And to sum up, developers love Morphia. Even the minions love them. Yeah, that's it. Any questions? Yes, please.
What with data migration? How do you do data migration?
So you mean if you don't just add something, but if you kind of change the structure?
Yeah, if you change your entity, but the data in the database is in old format.
All right, so for very simple things, you can probably just do that with a query where you just update a value. But if it gets more complicated, we are doing that in our application. So then we just have kind of the old version, and then we need to just, so you can easily read the old format, but we're also always writing the new format. So we're doing that in the application. So it's a little more work, but after like 2 months or so, everything that hasn't been saved and hasn't been migrated by the application to the new form, we just explicitly save, and then we throw out the old code so that we don't have to have this migration code too long in the database. But we have done some kind of difficult migrations where we just took out the information or combined it in a different way, put it into another collection. Unfortunately, that's only possible with application inside the application, yes.
And one more question. Morphia started with a separate project, but as far as I understand, the MongoDB company who is running MongoDB, like 10gen, is it supporting Morphia right now? They are developing it?
Yes, so the history is kind of sometimes a sad story. So in the beginning, Morphia was a community project. It started on Google Code. Then MongoDB, the company, then still called 10gen, but now it's MongoDB Inc., hired the main developer, and I was like, yes, now it's going full speed and he will be able to work full-time on Morphia. But unfortunately, the opposite happened, and he had to do so much other work that he wasn't able to maintain it anymore. And then someone from the community stepped up and copied the code from Google Code to his own GitHub project and provided versions there. So we've been using that for some time, and it was working well. And then the community just demanded Morphia more, and then MongoDB Inc., the company, said, okay, yes, this is important, we're taking it back. And then they took their original code from Google Code and put it into the official MongoDB GitHub repository, and took in some of the patches from the external contributions. And now the company MongoDB is actually working on it and pushing it forward. And that's also why the official Java driver is always in sync with Morphia. So they test it and it won't break. Because if you want to get new features, you normally need to get, first you need to get the up-to-date version of MongoDB to get the new features, then the Java driver needs to support it, and only then Morphia can support it. So it's kind of a way, can take a bit of a time, but the official company is behind it and is pushing it forward, so it should not be a problem.
Okay, thank you for the presentation. I'm wondering how Mongo resolved blob format or some big object, painting images, and so on.
Yes, so MongoDB has one document is limited to 16 megabytes of data, because whenever you read a document, you need to read the full thing from disk, put it into memory. Even if you want to transfer some of the attributes, you always need to load that whole thing. And they said, yeah, if you need more than 16 megabytes, you're probably doing it wrong. It will need a lot of memory. It will be really slow. So don't do it. In the past, the limit was like 4 megabytes, but that was 4 years ago or so. And now it's 16. And if you either have big binaries or your documents grow larger, you have this gridfs, which is the distributed file system. There, Morphia will automatically chunk whatever you have. So either a big text document or binary into 256 kilobyte chunks, add some metadata, which you can use for querying, and just distribute that in MongoDB. So that's how to use very big data in MongoDB. Okay, so you mean if you just try to fetch the data and at the same time somebody starts writing the same chunks? I'm not entirely sure. So I don't assume it's not transactional in any way. It's just fetching chunks. So if you have that situation, you might get a bad file. So you get some of the old chunks and some of the new chunks. I've never tried it out. And the problem with gridfs, it's not so popular because it's 10% slower like direct file access, because of MongoDB has all to do the work in the background. So that's why it's not so popular. It's a possible solution, but it's not so popular, especially for very high throughput. I would be careful and use something else. So I've not seen any reports of that, but I won't guarantee that it will automatically get the right data. We would need to look at the implementation, how it's handled in the background. I don't know by heart. Yes.
Thank you for a great speech. I've got two questions. The first one is about embedded object. in which manner driver or Morphia loads embedded objects. Is it something like n+1 problem when you use one query to load owners of those embedded objects and n queries to load those embedded objects themselves? And the second question is, does Morphia provide some caching abstraction like JPA does? Thank you.
Okay. Okay, so first, the embedding, there you don't need to do anything specific. So if you just put everything in a single document, the document is always loaded as a whole by default, and unless you specify that you don't want to load the whole thing, it will be loaded including all the embedded attributes. Yeah, embedded will be just put into the same document. Do you mean reference? Reference. Yes, so this is a separate query then. So yes, you will have the n+1, so you will get the first thing, and then if you have a list like referencing 20 other documents, you will fetch each of those documents then, yes. So that's why you should be kind of careful, and if we know we have a very big list, we will just make these queries explicit and not try to fetch it automatically, because it won't happen very well. Concerning the caching, I think there was some kind of implementation for the caching, but we're definitely not using it. We are using Spring annotations for caching and putting that into Hazelcast, the in-memory grid, just to distribute that. But on the other hand, like MongoDB queries are not that complex. So normally, unless you have a specific scenario, you would just try to make the queries faster and get the data faster. From MongoDB, because you don't have any complex joins or anything, it's kind of like, get me this document, it should be quite fast. So I'm not sure if it's that common to have this query layer, because it introduces lots of problems, and probably you can solve the caching on a higher level in a more efficient way in any way. So it doesn't have this automatically second level Hibernate cache, for example. I assume you mean that, yes.
Thank you for attending the conference. The question is, a year ago when we were considering whether to use direct Mongo driver or some object-relational mapping framework like Morphia or Mongo or Spring Data, the problem we appeared like, particularly in our application, the input was a JSON that was message broker messages and probably REST messages, but in any case JSON. And we understood that in Mongo it is also stored as binary JSON.
Yes.
And when considering between to use ORM or not, the main problem which appeared, apart from maybe some performance benchmarks, but the main solution why we use direct Mongo driver, the main factor why we use it, is that we had a need to store some fields in object which can be of mixed type. So that maybe, let's say, JSON object or JSON array or whatever else. And in all ORM frameworks which we discovered, we have not found a solution how to solve the situation when, let's say, potentially we have an employee, but this employee may have field settings, and those settings may be everything. Do you know if there is possibly in Morphia, let's say, as the fastest among ORM frameworks for Mongo, as far as I know, is there a solution for situations like that?
Yeah, I guess you can store it like an object, but otherwise it won't really work, because it's kind of a type-safe mapping. So if you don't have a specific type, that's just not what it's used for, then you would probably be better off with the default Java driver. And if you have the string already, you can just do the serialize and don't need to put it together in any specific way. So if you just want to throw in the JSON and get out the JSON and don't need to do much Java processing, your ODM won't really help you that much, I guess.
Thank you.
You're welcome. Yeah, whoever gets the microphone first.
Dear participants, I'm sure you have lots of questions, but we have no time for this talk anymore. So you can ask your questions after the talk. And let's say big thank you to our great speaker, Philipp, today.
Thank you. Come to me if you have questions.